But what if we created a bunch of train test splits, calculated the testing accuracy for each, and averaged the results together? A much more statistical approach, right? So instead of creating one train and test split, you repeat this exercise that we saw up top multiple times, measure the accuracy on those different partitions of training sets, and then average their score out. So that is the essence of cross-validation. So let us discuss now the steps for k-fold cross-validation. We will split the dataset into k equal partitions or folds. Use fold 1 as the testing set and the union of the other folds as the training set. Calculate testing accuracy. Repeat steps 2 and 3 k times using a different fold as the testing set each time. And then finally, we'll average out the testing accuracy as the estimate of out of sample accuracy. And here is the diagrammatic representation of the narrative that we were just going through. So we take the data, we split it into train and test set, we split it into multiple partitions or folds, and in each iteration, we use a different fold as the training set, measure the testing accuracy, and then finally average out those training accuracies or testing accuracies rather. So in order to do it programmatically, we are going to first work on a dummy problem. We are going to simulate a data set of 25 observations so that we can visually confirm what's going on with this. So from scikit-learn's cross-validation, we import k-fold, and for k-fold, we specify 25 observations with 5 folds, keeping the shuffle equals false. You can put that equal to true and see what happens. So next, we want to print the contents of each training and testing set by formatting them in a fancy way. Let's see the output and figure out what's going on. So in each one of these iterations of k-fold, what we did was we took the training set and the first 4 folds, or rather 4 folds out of these 5 partitions that were created, went as our training set observations, and one other fold went as testing set observations. So if you watch carefully, on iteration 1, the first block of data 0, 1, 2, 3, 4 gets selected as the test set, while the rest of the data gets selected as training set. In the next iteration, we see that the second block 5, 6, 7, 8, 9 gets selected as the test set, while the remaining gets selected as the training set. And you can probably extrapolate the scenarios for iteration 3, 4, and 5. So the dataset contains 25 observations numbered 0 through 24. 5-fold cross-validation runs for 5 iterations, and for each iteration, every observation is either on the training set or the testing set, but not both. Every observation is in the testing set exactly once.